Hi, I'm Alan Downey, and this is an introduction to Colab for people who are new to Colab, Jupyter, and Python. Colab is an online environment where you can run a Jupyter notebook in your browser, and in the notebook you can run Python code and other languages. The good thing is that you don't have to install anything, but you do need a mental model of what's going on, or there are things that might be surprising and confusing. I should say I'm not affiliated with Google or Colab, so this is not an official video. I teach at Olin College, and I use Colab in some of my classes and with some of my books. So I hope this is useful, but I can't guarantee that it's error-free, especially if things change in the future. I'll use examples from Elements of Data Science, which is a new curriculum I'm developing for data science in Python for people with no programming experience. Suppose you've got a computer and you're running a browser, and I give you a link to a Jupyter notebook that's on GitHub. When you click on the link, you open the notebook and you see it in your browser. So let's see what that looks like. This is the web page for Elements of Data Science, and this is a link to the first notebook. So if I click on this link, it goes to Colab, it loads the notebook, and I can see it on the screen. When you start running the notebook, the first time you execute a code cell, Colab creates a runtime, which contains random access memory, which is RAM, and disk space. So we can see what that looks like. I'm going to use Shift-Enter to execute the first cell, which is text, so it just formats the text. It doesn't actually run any code. Until I get to here, this is the first cell that contains any code. It's very simple, it's just an integer. But when I run this cell, I get a window that tells me that this notebook was not written by Google, but we can run it anyway. And what's happening right now is it's creating the runtime on Colab. And we can see in the upper right here, it shows the RAM and the disk that we are now connected to. So your browser is connected to the Colab runtime, and whenever you run a cell, your browser is going to send a message to the runtime, it gets a response, and it displays the result. You would be amazed at the number of computers and the amount of computation that happens every time you run a cell, but mostly you don't need to know about the details. One thing you should know is that that runtime is on a computer that's owned by Google. So as a practical matter, you need network connectivity. If you lose your network, you won't be able to run code. Also, you should read Google's privacy policy and terms of service to make sure that they're appropriate for your project. Importantly, the notebook that you see is a copy of mine. So anything that you change in your notebook is not going to affect my notebook on GitHub or anybody else. You own it. But that also means that if you make any changes, they're not being saved unless you tell Colab to save your notebook. Let's see what that looks like. There are a few different places that you can save, but the easiest one is to use this button, which copies the notebook into your Google Drive. So when I press that, it tells me that it's creating a copy. And now I have a new notebook, and notice the name of the file says that this is a copy of the original file name. What you might want to do is give it a more meaningful name, maybe your own name or something like that. You can name this notebook whatever you want. And now, while you are running this notebook, the changes that you make are getting saved periodically. If you make a big change and you're nervous, you can also press Control-S or select Save from the File menu to save explicitly. Now, what's going to happen when you run a line of code like x equals 5, it creates a new variable named x and a value 5. The variable and the value are in RAM on Colab. If you leave the notebook idle for a while, it disconnects from the runtime. And you'll see a screen that looks like this. So if you go to lunch and you come back, you might see this that says that your connection has timed out. And what that means is that that runtime is gone, that has disappeared, but you still have the notebook, so don't worry, you haven't lost anything. You can load that notebook back if you need to. You can load it from Drive. And then when you run the first cell, you'll create a new runtime. And that new runtime will not have the variables and values that you had before until you run the notebook again. When you run the notebook again, you'll get those same variables and values back. That's enough to get you started for now. You might want to use Colab and just get more comfortable with it before you watch the rest of this video. Later on, we'll see some ways to copy data from other sources in the web onto the runtime disk. You can open those files and read them into the notebook. You'll see how to download data onto your own computer so that you can upload it to GitHub. And then also you'll see how to take figures that you generate from Colab and download those to other places where you can get access to them. Okay, welcome back. I assume you've been out using Colab for a while, and now you've come back because you want to know about these other topics. So just to review, so far we know how to open a notebook, we can run it, and we can save the notebook. The next thing you might want to do is get data that's on some web page that's out there in the web somewhere. I'm going to use Project Gutenberg as an example. So let's say that there's a file called 2600.txt. We'll use wget in order to make a copy of that file from Gutenberg onto the disk part of the Colab runtime. From there, you can use open in order to read the contents of that file into RAM and run your program and do whatever you're going to do with that data. That's a very high-level view. The details you'll see are in the notebooks for elements of data science. You can also look them up online. When you disconnect, let's say that you leave the notebook idle for a while, the Colab runtime is going to disappear. And when you start it up again, you're going to get a new Colab, but any files that you put into the Colab disk are not going to be there anymore until you run wget again. So you might find when you start up a notebook that you have to run those cells in order to get your data and put it back on the disk. You'll also see some examples where I've put data on GitHub, and you can use wget to pull that data and store it on the Colab disk. If you find some other source of data, so as my example, I'm going to call it datasource.gov, and let's say that they've got a file that's called data.csv. If that file has a public URL, in other words, if anybody can go to that web page and download the file, then you can use wget again. You can just pull that data directly from the source into Colab. But if you have data that's coming from a private source, or if you want to keep a copy of the data in a GitHub repository, you can do a process that's a little bit more complicated. So first, if you want to store things on GitHub, you need a GitHub account. And then you create a repository, which is a storage space for your project. Then you'll use a browser on your computer to download the file. And when you do that, it's going to go onto the disk that's on your computer. And then you can upload it from there to GitHub. And then use wget to copy it from GitHub into the Colab disk. And finally, you can use open in order to read it from the disk into RAM. So if you have a GitHub repository that you're using for your project, you can also use it to store your notebooks. And you'll see a way in Colab to store a notebook on GitHub. That can be a better way to organize your project so that all of the notebooks and data related to a project are in one place. That also makes it easier for other people to work with your project. But one thing to be careful about, when you put something into a public repository on GitHub, you are making it available for anyone to download, so you are redistributing the data. You need to make sure that that's allowed under the terms of use from wherever you got that data from. Finally, one last thing you might want to do. You've run your notebook, you've done your analysis, you've generated some figures. You'd like to now download those figures and make them available. So you've got the figure that's in a notebook. If you use savefig, which is part of matplotlib, savefig will save that file on the Colab disk. And then Colab provides a library called files that has a function called download. And when you run that, it will allow you to download those files and store them on the disk on your computer. One piece of vocabulary that might help you think about this, the disk on your computer is the local file system, and the disk on Colab is the remote file system. So download in this case means that you're taking something from Colab and downloading it to your local file system. From there, you can upload it to GitHub, and now it has a public URL, and you can use that to publish the figure and make it available. So that's a complete mental model of Colab. It looks a little complicated because there are a lot of lines there, but hopefully this will help you get work done and keep track of where your stuff is and not get too confused. Good luck!